Okay then guys, let's have a little say a few words about quadratics and cubics for this little section to get us started here. If we have a quadratic of this general form then, ax squared plus bx plus c equals 0. If we have this condition here, b squared is less than 4ac, or in other words the discriminant b squared minus 4ac is less than 0, then that gives rise to negative square roots, doesn't it? So we'll have complex solutions. So here's an example here. So I've just written out here. You've got x squared plus 2x plus 3 minus b plus or minus the square root of b squared, which is 4, minus 4 times a times c, which is 3, all over 2 lots of a. So we end up with this solution here. The minus 2 is fine. Plus or minus is okay. 4 take 12 is minus 8. So we can write minus 8 square rooted as root 8 times I, can't we? As is customary, all over 2a, which is 2, and then split this fraction up. Minus 2 over 2 is minus 1, plus or minus root 2i. This is complex. This is two complex numbers. One is the conjugate of the other, and that's what naturally arises whenever we solve a quadratic equation using the formula. We'll always get complex conjugates coming out as the roots if there are complex solutions, and that happens when the discriminant is negative, of course. So that's generally the picture with quadratics. We can extend or use that knowledge now to look at cubics and see what happens with cubic equations when we solve them. We know when we draw a cubic we're going to have like an S-shaped curve, up, down, up. So it's going to go up, up, or down, down. That's typically the two sorts of things. And there'll always be one real root, won't there? This curve, either of these curves, will have to cross the axis in at least one place. It can cross them in as much as 3 places, and then it will have 3 real roots. But these solutions can have one real root, and then it can also have 2 complex roots that arise from solving the resulting quadratic when you divide out the roots from the cubic. So for example, what we mean really here is take this cubic here, x cubed equals 1, this cubic equation. We can write that as a cubic polynomial. Let it equal 0, of course. Solve that. By the factor theorem we can put f of x equal to it and put in the value 1. We get f of 1 is 0 when we put the value in. Easy to see that. And that tells us by the factor theorem then that x minus 1 is a factor. So we can divide out the x minus 1 into x cubed minus 1, and that will give rise to a quadratic, and that quadratic in this case will have complex solutions, and that's in question 11, this example. But in general you're going to get a quadratic arising coming out from the division of a linear factor divided into a cubic. You'll get a quadratic which may or may not have complex solutions. If it does have complex solutions, of course, as in the previous comments, they will be complex conjugates of one another. So that's really it, the gist of quadratics and cubics then, guys, for the first few questions in this section. So all the best, and I'll catch you in the next section. Cheers!